Welcome, everyone, and good evening to all of the attendees. Thank you for joining. Thank you to Spectrum International for hosting this event tonight. We are truly excited about their collaboration, their professionalism across the globe, and the opportunity for more information to get out there about Smartlens Pro and how this can benefit your patients. My name is Alyssa Maesler, and I am the VP of Marketing and Sales at Acculens. We are located in Denver, Colorado, and I just want to introduce our panelists tonight. So we have Troy Miller, also from Acculens, on this webinar. He is our VP of Operations and our main product developer. He knows all of the inside and out of the product design and will be a great resource. And our keynote speaker for today and tonight will be Dr. Alex Gibberman, who is on the line. He is the main key opinion leader for us at Acculens, and I will let Troy introduce him.
Thank you, Alyssa. Yeah, I'd like to introduce Dr. Alex Gibberman. He's been in the industry fitting scleral lenses for quite a few years. We're very happy to have him as part of our team. We're very happy to have him out there helping patients see better, changing their lives. He's definitely an asset to the patient and the industry, as well as Acculens. So Alex, you talk a little bit about yourself, introduce yourself.
Well, thanks, guys. Thanks for having me. Good morning, good afternoon, or good evening, depending on where you guys are listening from. Yeah, for the most part, I have been working with scleral lenses pretty much since I graduated back in 2014, so just coming around 10 years now. And I had the privilege of really starting out with Acculens right out of the gate. Just a little bit of background on how I got started with sclerals. I really didn't get a lot of training in or during school, so I was pretty green to how the whole process worked. And Acculens was awesome. They had sent someone out to my office and basically did a crash course training with me. And that was, again, 10 years ago, and pretty much the rest was history from there. But what was great about that, and really not, at the time, not having a whole lot of peripheral training, is, I got a chance to really kind of start working, based on just trial fitting lenses and really just kind of figuring out what I was doing by trial and error. I made a lot of mistakes along the way, but I also think that made me uniquely qualified to help, teach people that were just starting out. And then, as I've kind of gone through the process of this over the last 10 years, we obviously learned a lot, and we've gained a lot of knowledge with the fitting process. And then we've also gotten to really watch a lot of the exciting things happen in the contact lens industry and a lot of the advances that have been made with technology over that time period. And Acculens for sure has been at the forefront of that. It's when we started 10 years ago, a lot of, we had a lot of patients that, would have benefited from scleral lenses where we didn't have that freeform technology yet. We kind of, we understood that there were only so many changes that could be made with lenses. And Acculens really has been a leader, during that time period of making sure that they've stayed at the forefront of technology. And as new things have come out, they've really kind of punched above their weight as far as what they can do with their lathe cutting and with their CAD/CAM softwares. And there's just so many different things that you can now do with their lenses. And I guess in a nutshell, that's why I love it so much. I've had the opportunity to work with some other labs, and there's a lot of great lenses out there. But at the end of the day, it's really nice to have one company, one lens, with the Smartlens Pro with Acculens that can really pretty much do it all. It doesn't matter if you have a quote unquote normal cornea, dry eye patient that really is just kind of interested in getting better comfort and maybe more stable vision during the day, or if you have the most advanced keratoconus patient or post-graft patient or whatever it may be, it's really nice not having to worry about, hey, can I make changes to A, B, and C without it affecting something else? And so we've got some examples, and we'll kind of walk through some of the different things that the lens is capable of. But you could almost summarize this entire thing by saying if you can dream it, you can pretty much put it into the lens, and all of the things that you can do, whether it's to the front surface or back surface to the lens, none of them are really mutually exclusive of one another. So, if you wanted to put a front toric with a freeform back surface design, with a multifocal, with a vault over a pinguecula, if you wanted to move the optics to offset things, you can do all of those things. So, it really doesn't matter what your patient's eye is throwing at you. The lab is going to be able to handle it. And I'll let Troy kind of talk about some of the updates with the lathe cutting and CAD/CAM software that they've implemented. But I've actually gotten a chance to go out there. It's been a few years since I've seen it. I'm sure it's been updated even more since I've been out there, but it's really amazing what they can do.
Yeah, thanks, Alex. It's like you said, in a nutshell, you can, whatever you can imagine and dream, we can put into a lens design. Smartlens Pro really enhances the attributes of lens design itself. All Smartlens Pro scleral lenses, they're completely custom for every single patient. There is no one-off, there is no inventoried product. You trial fit, we design based off of trial fit. Simple things that are today, they didn't used to be. Vaulting pinguecula or other anomalies that require specific positions and elevations, those type of things can be done. Another important thing is offset optics for multifocals and special requirements such as off-center pupils, etc. That can also be done through Smartlens Pro. The manufacturing environment here at AccuLens is state-of-the-art. The company utilizes the latest technology in, like Alex said, CAD/CAM systems, lathes, etc. DAC lathes being one of the premier manufacturers of equipment for this industry is utilized here. Another attribute we have here is an MRP system which operates the whole company. Focal points. It's the latest in the CAD software that directly transfers the information to the machine. So electronically, what you can dream up can actually be machined. Material technology is another very important aspect of what scleral lenses are today, and Smartlens Pro, of course, is utilizing the best in hyper decay materials for patient overall health for their corneas.
And that's been a really nice change too, right? Because, years ago we kind of had the materials were good. They were always good. They were never bad. But, having the extra option to go all the way up to a 200 DK material, sometimes that is the difference between, that kind of high risk graft patient being able to wear a lens all day and versus not at all. So, it's just one other technology upgrade that's really all these little things that may or may not have knocked certain patients out of being able to utilize scleral lenses. The material, sometimes that gets overlooked. We just take for granted that we have had good materials for a long time, but just having these options to go to that hyper 100, 130, and then all the way up to 200 DK materials has been really nice. And the wettability is still really good. I mean, there are times where, we do utilize things like HydroPeg to enhance that. But for the most part, that's not really been a barrier to clear lens wear during the day. So that's really been a nice update for sure.
Thanks, Alex. Also, when it comes to the Smartlens Pro trial set, these are also manufactured in the hyper decay material. They come in an 18 lens trial set, and we try to cover everything with Smartlens Pro trial set, 15.5, 16.0, and 16.5 diameters. It's not necessarily, going to be one lens out of the trial kit is perfect. The idea is to utilize the trial lens, and they are toric, bisphere elevation, and to assess that fit and give us the information and feedback, so we then can take that information and truly turn it into a freeform design. Quick start guide, troubleshooting guide are very important as part of this trial set. So please, reference those.
I'd like to comment on the diameter stuff as well, because there are a lot of other labs and companies where they kind of have their preset diameters and say, all right, here are the lenses that we have. We can change a lot of parameters within them, but you're kind of stuck using that exact diameter. And I cannot, stress enough how useful it is that with AccuLens and Smartlens Pro, the 15.5, the 16 and 16.5 are simply starting options. They're the lenses that are in the trial set, but you're not limited to that. And sometimes, you might have a patient with a really small corneal diameter. You might have a patient with megalocornea or just a really large diameter and cornea. And with the HVIDs being different on everybody, it's really nice that, sometimes you don't want to have to change the diameter by a full millimeter. You want to go in incremental steps. And with AccuLens, you can specify if you started with a 15.5 lens and you just feel like you need that little bit of extra, maybe it's a limbal clearance issue, or maybe you're just trying to avoid landing directly on a pinguecula. Maybe you don't feel that you need to vault over top of it. The diameter is another one of those parameters it's actually super easy to change without it really affecting without it affecting anything else. And it's really useful to have that as a changeable parameter, because that's not always available on other lenses. Which actually leads me to the next point, which is that's exactly if you're utilizing a trial fit, the first thing that you're going to do is exactly that. You're going to take a look at the HVID, and just to get a starting point or starting idea of which size you're going to choose, you're going to go 4 millimeters beyond the HVID. So if you have an HVID of 12, you would select the 16.0. And for trial fitting sake, if the HVID is larger than 12 millimeters, then you would go utilize the 16.5. If it's smaller than 12 millimeters, you would utilize the 15.5. So that's kind of step one with selecting your initial trial lens, is simply figuring out what your HVID is and selecting the appropriate starting trial lens. Step two is then taking a look at the limbal indicators. And this is a really, really, really nice tool that AccuLens has built into these trial lenses, is they've placed these dotted lines that are at the limbus. And you can basically just take a look at where the limbus is cutting through those lines. And I think we have a blown up picture of that later on. So we'll get a chance to take a look at that. But that's a really useful tool of just making sure that you've started with the right size lens. And again, you can adjust just simply the limbal curve, or you can elect to increase your the diameter of the lens. Either way, that's a way that you can address that. Step two is probably looking at the central clearance. So that's where, something that we're all used to doing already, just making sure that we have the appropriate amount of central clearance. And then the third is evaluating the edges. And what's beautiful about freeform lenses and about, again, where we started with where we're at now is, we had spherical back surface optics. We've had that for a long time. Then that kind of transformed into back torics, where you could kind of adjust two principal meridians. Maybe you had the steep and the flat axis at 12 o'clock and 6 o'clock, and then you had it at 3 o'clock and 9 o'clock. And then that migrated into quad specific lenses, where you could adjust 4 quadrants. And then that gave way to freeform lenses, where you can pretty much address any single clock hour, whether it's too tight or too flat at any given area. And what's really, again, I think special about this is that it doesn't have to be in principal meridians. If you have an issue of tightness at 10 o'clock and you have an issue of an edge being too flat at 3 o'clock, you can adjust both of those edges individually, and that is totally doable with this lab. The only thing is you just have to make sure that you're noting where that trial lens dot settles, because obviously that rotation matters when the lab is adjusting those edges. And then at this point, the sky is the limit. You know, if you have a lot of patients with whether it's pterygium or pinguecula, all you're basically doing at that point is noting the location, the clock hour, where those things are located, and then if possible, measuring how big and how high they are, because those things are adjustable within the lab, within how they can cut the lenses. And then you're just basically sending as much information and as much data as possible to the lab so that they can create the ideal lens right out of the gate. So it's a really, really powerful tool as far as all the different things that you can adjust. Now, if you're fitting multifocal lenses, the AccuLens has created what they've called the on-point system. And again, we talked about those limbal indicators that you see on there, but there's an entire grid system in the middle that helps to measure centration. So, you know, certainly we all know that a lot of times lenses will decenter inferior or inferior temporal, or sometimes even temporally, just based on the anatomy of the eye. When you're dealing with multifocal optics, certainly that's problematic if the lens is decentering, because that multifocal zone, although adjustable, is only maybe 2 or 2.5 millimeters in diameter. So it is really beneficial that you can adjust the zone size of the multifocal. But even going beyond that, if we know that the lens is decentering in a certain direction, wouldn't it be helpful to be able to measure how much it's decentering, so that the patient could take full advantage of the amount of multifocal power that they think that they're getting and that we think that they're getting? And that's basically what AccuLens did here with designing this this system. So it's really simple, and this is basically engraved in all of the trial lenses. And you're just looking at it in the slit lamp, and you're basically recording the direction and how many notches are inside the pupil. And so basically you're taking a look at whichever direction has the most notches inside the pupil. So if it's going, for example, if the lens is sitting inferior temporal, in this case, it's, you know, you're going to look at that 135 meridian, and you would count 2 tick marks fully inside the pupil, and you would relay that information to the lab so that they would actually know how to offset, and I should say recenter the optics, to get the optimal viewing power for the patient. So this is, it's something that's super easy to see. It actually, the patients can't see it. It's faint enough that it doesn't affect their acuity at all during the trial process. But it's helped us on a number of occasions. And so it really just, it's that next level of vision with multifocals with scleral lenses. Do you want to add anything to that, Troy?
No, I think you hit every point. I believe.
So
Again, multifocals definitely, of course, and that was the main focus of this system, but also offset pupils. We can adjust the position of the distance zone for those types of patients. So yeah, it's definitely a huge tool. It's benefited a lot. It's increased the amount of patients out there wearing multifocals, as a matter of fact. So.
And so even just to piggyback on that point, one of the other really great things I think about AccuLens and their multifocal profile is that they in fact have a multifocal profile. They have a lot of different multifocal options available. So this particular system is really meant for the center near the center ad design multifocal, but they also have an aspheric distance centered multifocal. And we've taken advantage of a lot of mixing and matching and kind of playing around with the different types of multifocals that are available to us. Just like with soft lenses, there's not a one size and one, contact fits all multifocal. Depending on the patient's anatomy, depending on their brain, what their needs are, different people need different things, and it's actually really great having some of these different options. So, for example, a lot of times we'll take advantage of using an aspheric distance-centered multifocal that might have a slightly lower ad power, say plus 150, plus 175, and putting that in the dominant eye. And then we'll take the center near lens and we'll put that in the non-dominant eye and put a higher ad power, and then that gives patients maybe a little bit better range when they're looking on a computer versus when they're looking at something right up close. So, it's kind of we'll call it a modified monovision, if you will. But there's no right or wrong way to do that. It's just one of those, it's another tool that's available to you. And I think that, the more stuff that we can offer to patients, I mean, sometimes we maybe shoot ourselves in the foot by offering too many things, but at least we have an idea in our head what's possible. And if people are having issues or they want something different, we can pivot without just saying, oh, sorry, this doesn't work for you. So, just to review, you can have aspheric multifocal, you can have center near multifocal. They've even come up with an alternating zone multifocal. That's a little different. And then you can change the zone size and you can decenter the zone to match the pupil. So all sorts of really, really powerful tools built into that trial lens system. So
Dr.
that's
Alex,
kind of, and I'm sure if you guys have any questions about that, fire away.
they do. They have 3 questions. So one of the first questions is the on-point technology is really great for trial lenses. But if you need to troubleshoot your first lens because it's still decentering, are the patient lenses also marked? And how do you track decentration then?
So when the lenses come back, they're not marked, but the idea is, that since the initial lenses are back toric, you're already you're already going to be able to see the rotation of the lens on the eye, and you're going to see the direction that it's decentering. Questions do pop up every now and again of, well, what happens if I've adjusted the limbus, and what happens if I've adjusted the edges? Won't that center the lens more? And the answer is yes, it should center the lens more. But I think, and correct me, Troy, if I'm wrong, you guys do kind of take that into account when you produce the lens. But there are no markings on the actual final lenses that come back other than the dot, which should, you should be able to kind of match up that rotation and kind of make adjustments accordingly.
Yeah, that's absolutely, that's correct, Alex. Surprisingly, through thousands upon thousands of patients who we've consulted and fit, strangely enough, the offset that you see in the trial lens is very much mimicked in an RX lens, regardless of whether that RX lens is actually bisphere elevation or in most cases freeform. The lens will still decenter, typically downward and out, but it does mimic very much what the trial lens was.
And you do have some wiggle room too, because of course the pupil's not a pinpoint, right? I mean, if it is, then you would have to adjust the zone size accordingly. But assuming you have a relatively average pupil that you've taken into account, as long as you've centered it in the correct direction, you're going to be a whole heck of a lot closer to a perfectly centered. Even if the amount of decentration changes a little bit after the final lens comes in, to Troy's point, it's still in the same direction, and you've moved that center point a lot closer to where the center of the pupil is. So there are symptoms of glare or halos, or even, just not getting optimal near power, a lot of times is fixed. And if anything, when you get that initial lens back, it's usually not the direction or amount of multifocal that's an issue. It's, if anything, usually it's just a matter of, is there a little over refraction left over or something like that, that the patient may benefit from, just like any other multifocal. Sometimes people have to try it for a little bit to let you know, hey, I'd like a little bit more near, hey, I'd like a little bit more computer. And that's kind of how we troubleshoot that. You can always, if you're not convinced, you can just use your finger and push the multifocal in a direction, and the patient will let you know right away, hey, that made it better, or hey, that made it worse. And you can always relay that information onto the lab too, if that's happening. Although that doesn't come up a ton. And then I think I saw the other question was, how do you know which multifocal to start with? Again, I think part of that depends on, and this is just my fitting philosophy. If I have an early to mid presbyope, say, early to mid to, even late 40s, we may actually utilize an aspheric multifocal, distance center multifocal on both eyes, just because the ad power is less. It's a little bit more forgiving if it's off center a little bit. It's just giving that little bit of a boost up close. It doesn't really affect the distance all that much. And then, but the caveat to that is, if the lenses are decentering quite a bit, I might go for that center near multifocal right out of the gate. You can still specify what ad power you want in there, but sometimes we may find it to be more beneficial to make sure that we've centered over the pupil, as opposed to just going with a distance centered multifocal. So it kind of depends, but again, I would say aspheric multifocals on the earlier presbyopes, center near multifocals on the slightly older patients, I guess. And then it also depends on need. Like I said, I actually like to take advantage of putting an aspheric in the dominant eye and center near in the non-dominant eye, and I actually do that for all ages. And I find that to be the most successful overall way to do multifocals.
Doctor, two more questions.
Sure.
Is the center near lens concentric or aspheric?
The center near is concentric.
Perfect. To troubleshoot multifocals, do you change the ad powers, or what would you need to do if we can't track the decentration of the lens once it's ordered?
So I don't typically adjust the ad powers. Usually I would try and, if somebody wants to do a little bit, if they say, my distance is good, if the distance is good, that's easy, right? If they're happy with the distance, that's usually, and the issue is up close, then a lot of times I would try just a half step of at it. I would use a loose lens and hold it over top of the center near lens first, at least, and then I might try it over top of the aspheric one as well. But sometimes a half step of added plus is the answer to better near in just one eye. If the issue is distance, the first step is making sure that there's not a spherical or spherocylindrical over refraction, because sometimes the issue is astigmatism, not necessarily the multifocal. So it's important not to forget about that. I honestly utilize a front toric on probably 75% of lenses, even if it's only 3/4 of a step. A lot of times, especially in multifocals, we find that if you ignore that, it just becomes too noticeable. So I do like to include that if there's any benefit at all to sharpening up that vision. And then I think if we've tried the spherocylindrical over refraction, we've tried a normal just holding lenses over, and the distance is still a problem, that's when we may try and adjust the type of multifocal, or start playing around with the using our fingers to play around with centration. But believe it or not, that just it doesn't come up a whole lot. And if people are failing in the multifocal, it's usually not necessarily because that they're having an issue with the centration of it. They may just not be you know, a multifocal brain person who maybe that's a more of a monovision person. And of course that happens just like it happens with soft lenses. It can happen with scleral lenses as well. But that's kind of the steps that I would take. You know, make sure that the lens is centered just based on the eyeball test and based on where you started from. But then trying all those other things before we're adjusting the type of multifocal or the power of the multifocal.
Great, Doc. There's one more question, so we can go ahead and proceed. Can we adjust the lens centration due to scleral toricity with these marks? And how many quadrants specific do we need to go steeper for every one line of all these marks at optical zone?
So a good question. These marks are not necessarily for edge design, right? So you're really using you're using the on point, the center grid system is specifically for multifocals. Or if you have a patient with a trauma and they have a different pupil location, the limbal indicators are really just making sure that you have enough limbal clearance. So you really want the limbus kind of slicing between the first and the middle line. If it's beyond that, if the limbus is going through B and C, and certainly if it's beyond C, then you basically just have a lens that's too small. And the first step would be making that lens bigger. And then increasing limbal clearance accordingly. But as far as utilizing the limbal indicators for your edges, that's not really what those are for. Although I think, Troy, if I'm not mistaken, you guys did put a limbal amount value to those, did you not?
As far as the limbal curve indicators?
Yeah, like if it's maybe just like if it's going through, say, if it's right at C, as far as saying, well, we would recommend trying to add like 50 versus 100 microns of limbal clearance or something like that.
Yeah, correct. The biggest adjustment we'll make is going back to the whole philosophy of trial fitting based off HVID. So if we do find that the lens is too small or too large, typically 2/10 larger in diameter, as well as optical zone diameter, would make the change. And what this means, the limbal curve indicators showing up like that, is that the lens is either too small or too large, and so adjustment is done by diameter. However, we can increase the specific zone angle or curvature over the limbal area in order to increase limbal coverage.
Right. So that's a great point, is you don't necessarily have to increase or decrease limbal clearance everywhere. You can specify where you want to do that. So that's one of the great things about the freeform design. The freeform design actually starts the part of this that makes it freeform actually begins inside of the limbus. So you can really adjust those limbal curves anywhere. It's not just limited to, if you're not saying, well, I want to make limbal clearance larger and making it larger everywhere. You can do that, but you don't have to. So you can specify, how you want to go about doing that. And I wanted to real quick circle back to the last part of that question, which is, how many microns, or how do you know how to adjust the edges? AccuLens basically, they use what they would call a step system. So you can specify it in any quadrant. If you say, hey, I want to tighten this lens one step at 12 o'clock and leave it the same as the trial everywhere else, one step means 70 microns, and they can actually go in half steps. So you can even specify 35 microns if you wanted. But each step of change is basically about 70 microns of tightening or flattening. And you can do that at any of those quadrants. So hopefully that helps answer that question a little bit. Although again, you're basically using your knowledge base and experience as to looking at how flat or how tight a lens edge is and deciding how much how many steps or how many microns of tightening at the edges that you want. And again, you can do that at the edges in any clock hour. You can do it at the limbus anywhere as well. And one of the things that our practice has been able to utilize in the last couple of years is the eaglet, the eye surface profiler. But you know, if you have access to or have a pentacam, it basically works the same way. And that's helped us gain a lot of knowledge about the anatomy of our individual patients. You know, sometimes you can have a lot of toricity, or you can have a lot of different elevations, and it's all at the edges. And so just adjusting the edge profile is helpful in those cases. But sometimes we find that you can actually, and with those images, Troy's able to do this at the lab as well. They double check all of it. There may be that there's a lot of extra toricity or freeform shape at the area of the limbus. And so actually accounting for those kind of elevation changes at the limbus can help better center a lens instead of just putting all of it at the edges. And that's really one of the things that the Smartlens Pro has done. And I see somebody ask, what's the difference between that and Maxim 3D? I think it's just depending on where it's distributed. It's called two different things, but it's the same technology. Does that help answer that question?
Did. Thank you, doctor.
Yeah. How do you adjust for pupil size in your multifocal? So that's another one where you know, you basically I actually have a case that I had this exact kind of issue come up, which is, you know, I had a patient with trauma and had a brain bleed, and she has a mid-dilated pupil on one side and a normal side. I think, you know, off the top of my head, I think one pupil was 6 millimeters and the other one was 3. And you know, that's one where you basically address that by increasing the zone size of your multifocal. You know, if you have a bigger pupil, you simply make the zone bigger. If you have a smaller pupil, you make the zone smaller. You want to try and mimic that the best you can. And again, Troy, correct me if I'm wrong. I think the standard zone size is 2.5. Is that correct?
That is correct, and that's based off of, you know, just standard data for an average pupil. Target optically is about 80% of the ad zone within visual axis.
Yep. So that is I mean, that's something. Now, interestingly, like, you know, that particular case in that patient, it just so happened that the trial lenses that we put on, they were about the best, most well-centered lenses that I've ever seen. That, you know, rarely does that happen where a lens is just perfect with centration. So we didn't necessarily have to utilize the on-point system to decenter the optics at all, but we were able to utilize adjusting the zone size just to account for the two different size pupils. You know, especially because the mid-dilated pupil isn't necessarily, it's not, you know, constricting in sunlight, and it's not really getting bigger in the dark. So we kind of know you know, what that pupil's doing, but it's still nice to cut down on any unnecessary glare or halos just by adjusting that one piece. So a lot of really cool stuff. And of course, you know, we do not put every patient in a multifocal. Not every patient wants a multifocal. But for the ones that do it, most of these patients that come in, they don't even know it's an option. You know, a lot of them have been told previously that, you know, here's the best we can do is your distance correction, and you know, use some readers over top. But just like with soft lens wear, there's a lot of patients that would love to have the option of getting out of their glasses, and just nobody's brought it up before. So not only do these lenses give us that option, but they give us a lot of different ways to tweak it and try and make it better. You know, I mean, anybody that's fit multifocals knows that you're going to have some patients that, you know, you could have done everything right and they just don't like it, and that's going to happen. But at the end of the day, for the patients that do like it and that are interested and that are, you know, understanding that yes, it's still simultaneous optics. Yes, you're still looking at distance and near. No, it's not as good as your, 18-year-old perfectly healthy eyes, but it does give you, say, 80 to 90% of your distance and reading, to the point that you're able to accomplish the things that you want to do. I mean, sir, I'm very big on setting expectations, and I don't want to say that it's under promise, over deliver, but that's kind of what we're able to do. And just reminding people that, hey, we can adjust these things. If they're not perfect right out of the gate, usually it's a small adjustment of power, and then we get there. But in the offset, you're saving yourself a lot of time by just simply utilizing the on-point system to make sure that you've got a good fitting lens and a well-centered lens, even when you order it out of the offset.
I want to just add one more thing to Alex's point. When you're talking to the patient, make sure you interview the patient. What's the patient expecting? Make sure that their expectations aren't too high, and let them know there's going to be a compromise. But it's always important to interview them. Are they using more computer during the day versus up close, or do they prefer more distance as opposed to intermediate or near? So you can focus on selecting the correct multifocal. We stress that on our end here at AccuLens to make sure you interview the patient.
And then, and also, I remind people about neuroadaptation all the time, which is, just like with any other, if they're new to multifocals and, or new to this type of multifocal, and that's usually the case, it's the type of thing that does tend to get a little better the more they wear it, as they kind of get used to it. And it's just like anything else. If you put someone in a multifocal or monovision soft lens for the first time, and they're immediately like, I hate this, I don't want it, blah, 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 then that just may not be a good patient for that, right? But if their initial reaction is, yeah, distance looks pretty good, and oh yeah, I can see up close, and that's another thing. I really like to, before we put before we put the multifocals in, when we get them, I kind of like them to look at something with just their distance correction on to show them the difference. Sometimes we kind of forget to do that. We say, well, here's your lenses, here's something up close, and what do? They reach for the absolute smallest thing that they can find and hold it 1 centimeter from their eyeball after you've just told them not to do that, and they struggle. But if you're showing them, hey, here's what distance only looks like. Oh, now let's put these in. Let's see what we've gained. It's more than likely going to be better. Let's see. So when you mention different zone sizes, can you adjust for intermediate vision as well, or just distance and near? So I don't know that it's possible to simply make the intermediate zone bigger. Is that correct, Troy?
For multifocals,
Yeah.
yeah, typically. So it all depends on what image you're trying to project back on the retina, and normally, since there's no accommodation left, progressive optics are by far the best solution.
And I think that's where, if your goal is intermediate vision, that's why either I would go with the aspheric distance centered lens, because the add power is lower for that. That's typically going to be your 1 1/4 to 175 range. So, we talk about, zone sizes definitely can make a difference, but that's where I think somebody earlier asked about the type of multifocal. And this is where it's good, to Troy's point, to kind of interview the patient ahead of time about what they're trying to see. If they spend most of their time on a computer, regardless of how old they are, I would want at least one of their eyes to be using that aspheric distance centered lens, because that's really more geared towards intermediate vision. If that's what they're doing 90% of the time, that would be a good time to potentially say, let's put this in both eyes. And then if you really need to use a light reader for some stuff up close, you can do that, but at least you've solved your distance and your intermediate vision with those multifocals. And then for everybody else, it's not a bad idea to basically put the intermediate vision aspheric multifocal in that dominant eye, and then the center near lens in the other one. So that's where I think it is helpful to play around with the different types of multifocals, but also trying to understand what the patient wants out of the offset, trying to understand what distances they're trying to be able to see. If somebody is, I don't know, a plumber or whatever, painter, and they're really looking at really close stuff up at near, then you might be looking at center near lenses and adding some plus into one of them. So it just kind of depends on the patient. If we adjusted the pupil position using the on-point, would it create any prism effects? And if so, how does it affect the rotation of the manufactured lens in comparison to the trial lens? So because honestly, because the trial lenses are toric, it's the dot should be rotating to the steep meridian, or at least the steepest meridian, I should say. So in general, you're actually trying to eliminate some of that prismatic effect, but that's not really, again, that's, I don't know, I don't want to say surprisingly, but it if anything, you're really reducing any of those kind of blurry or prism effects by recentering the optics. I don't want to call it, I know it's not technically angle kappa, but that's what you're trying to kind of perfect there. And then the key is basically when the actual lens comes in, noting any other rotation, you want to see where that final lens dot is rotating to. Because that's also something where a lot of times the lab will try and, just from cosmetic standpoint, they'll move it back to 6 o'clock. So that's not something where you don't want to rotate the lens with your finger back to 6 o'clock. But if the goal was to basically take your initial rotation and say, all right, we want to place that dot at 6, because the patients or their family or friends or coworkers don't want to be able to see it. And then you look at that final lens and it's rotated 30 degrees in the opposite direction. That would be something that would be maybe unexpected, maybe that happened with some of the other adjustments that you made in that initial fitting process. And that would be good to relay back to the lab, because then they would want to re-rotate that lens accordingly to try and recenter everything. So I guess that's kind of what you're using as your final centration rotation comparison, is where is that dot in relation to where it's supposed to be.
Yeah, any other questions before we move on?
No, I think we're good. Let's go ahead and move on.
All right, go into extreme fits.
So, and basically, one of the other, it's kind of what we've been talking about with these trial lenses is there's no limits. Again, we work with some labs where you can only change certain quadrants by you can only have so much toricity, so much of a shape change. I'm sure we've all seen patients where, especially like if they've had EOM surgeries, occasionally it comes, with blebs and glaucoma surgeries and things like that, tube shunts. You may have really significant local elevation changes in the sclera. And although, there are probably eventual limits to what the lathe can cut, AccuLens's parameters are far beyond, I think, what I've encountered with other labs, unless you're going with an iPrint kind of a molded lens, for those off the wall, type of problems. But for 99.9% of the elevation changes on the eye, whether it be an EOM surgery patient or just somebody with really funky anatomy, a huge pinguecula, pterygium, what have you, those 800 micron differences, it can be handled. Those are, I'm sure you guys have all seen those images of people on Facebook on the scleral lens practitioners group twirling around the really funky looking sclerals on a plunger, and they look nothing like a round edge, and that's where you run into those really kind of crazy edge designs. And they can pretty much handle all of that. And the AccuVault system has been a really nice addition too, because back in the day we used to have to truncate lenses where we'd basically be chopping off either the bottom, or we would be notching the lenses, which was all done by hand, which was fine, except there was a lot of there was a little bit of guessing, and there was a little bit of artistry to that. Occasionally you might have a notch, for example, that was well centered over the pinguecula it was trying to vault over top of, but maybe it was just a little bit too deep, and there would be air pockets that would be introduced into it. And so the vaulting system has been great, because that's basically just creating that micro vault over top of the pingueculas. And then if you have a way, or if you have like we're able to utilize our eaglet technology, it can actually measure the exact location, height, size, depth of those pingueculas, and then those vaults are basically custom designed in the lab with that CAD/CAM software, so that they're just right. They're not too big, they're not too small. And again, the lenses, it takes some of the guesswork out of it for patients, because although we tell them, hey, try and aim this in the general direction, right? Try and have that dot at 6 o'clock so that, the vault goes to the right place. It should rotate itself appropriately into the right spot. What is the highest elevation that you can go in AccuVault? I will let you answer that, Troy.
Well, most of the time, we found that the highest elevation is in the range of 500 microns, and most of that is due to a tool adaptation from the lathe itself. Clinically, it's extremely rare that I've ever seen anything over 300 to 350 microns. A lot of times, if they are irritated excessively, you're going to get that higher amount needed. But we found that once irritation has been reduced, you probably have to reassess and change that AccuVault to more in line with what the actual pinguicula elevation is when it is not irritated.
And again, it is nice to be able to utilize that vault in addition to all the other changes. So again, that's kind of unique. Some of the other labs, you can have vaults, and you can have front torics, and you can have back torics, and quad specifics, but you can't always have all of them together, and especially with multifocals. And with AccuLens you can. So if you have all of those issues, you've got that patient that wants a multifocal, but they've got a residual astigmatism, they need the front toric, and then they've got 400 microns of elevation at 12 o'clock, but then they've got a flat area at 8 o'clock, and then they've got all those things, right? They can all be incorporated into the same lens, and you're able to do it all at once. So that's really nice. What is the maximum toricity that you can go? So are you you're saying maximum toricity on the front, or on the back, or at the edges? Like what's the largest spread that can be handled as far as like elevation changes?
I think that was the question, doctor. Yes. What is the maximum toricity in the periphery that you can add to the lenses?
Gosh, Troy, do you know what I would again default to see what the lathe is capable of. I can just tell you, if in our experience, we've had some crazy elevation changes. Actually, we've had patients that we fit, we tried to fit 8-9 years ago, right when we started, and the technology wasn't there yet. And those patients have come back, and we've actually been able to refit them in the AccuLens lenses because the amount of freeform and toricity has increased by so much. And again, I don't know if we could put an exact value on that. Maybe Troy, that's a better question for you, if you know what the actual limits of that spread are.
At current, there really isn't an established limit. The only limiting factor is, again, back to the same factor that we incorporate into AccuVault. It's limitations on the machining capability and the tooling that can always be changed, but for the most part, on average, we see doing anything in the 600 to 700 range not to be an issue for us.
Yeah, and I've
as
had
far
plenty
as,
of
yeah.
patients in that range. That was going to be my guess is, we've had those 600-700 micron differences, which is a lot, right? That's not typical, but it does happen. And that's been handled fine. And that's not always the case with other labs where they've put those limits on how much toricity you can have. Really, the only patients that we have that we've run into issues with reaching certain limits is those, and again, this doesn't come up a ton, and it depends if you see a lot of glaucoma surgery patients, but if you've got the patient with the really large blebs, sometimes those do require a molded fit, where you've got a more of a totally a giant local elevation, but that again it's not typically what we're running into, but if I would say that's the one time that we would run into limits, it would be with a bleb.
Is there any other questions before we move on?
I don't see any more questions, Troy.
All right, Dr. Gilberman, if you want to go into your 2 trial fit cases and review those.
Sure. So this actually a patient I saw this past week or two ago. 74-year-old female presented with pretty significant dry eye, and we do get a decent amount of referrals for your from severe autoimmune and Sjogren's patients and whatnot. This particular patient had some lag ophthalmos after blepharoplasties, among other things. She was dealing with some pretty chronic dry eye that was affecting her vision a little bit, but more or less, her vision was okay, right? Her vision, even in glasses, was best corrected to almost 20/20 in both eyes. But she was someone that, was really interested in contacts, and she was looking for something that would help with her dry eye as well as give her the option for multifocal. So that is why we decided to utilize these lenses. I alluded to this earlier. This was the patient that had different HVID in both eyes. One pupil was larger than the other due to some trauma. And so this is actually a patient where we're able to, using her HVID, we selected our initial lenses. And you know what? I apologize. I'm getting ahead of myself. This patient had asymmetric pupils, but she also had asymmetric HVID. So 2 different things that we were kind of looking at here. Her HVID in her right eye was smaller than her left eye, but her pupil was actually bigger in her right eye. So she had a smaller cornea, bigger pupil in the right eye. So based on the initial HVID of the right eye, we were able to we selected that 15.5 millimeter lens, and just had a spherical over refraction, had really good vision with the trial lens, and the lens was really well centered. So using the on-point system wasn't so much the issue as just dealing with the larger pupil size on this eye. So the question was going to be, were we going to utilize a larger zone size for that pupil versus not having to do that? And sometimes, if it's close enough, you just you don't always know right out of the gate. You try one and then see if there's symptoms and kind of go back. But she ended up doing and should continue to do really well utilizing that lens. On the left eye, if you notice, the HVID is above a 12. However, we could have used the 16.0 Smartlens initial trial set. We ended up using just the same size because knowing if all else looked good and the only issue is just maybe not quite adequate limbal clearance. instead of going all the way up to, say, a 16, maybe we would just increase it a little bit. And that's exactly what we ended up doing. I think we went from a 15.5 to a 15.8. So we just increased that diameter just a little bit, enough to gain a little bit more limbal clearance. We did also want to address the fact that this lens rotated 40 degrees out of the gate. So as far as utilizing a center near lens on this eye, we wanted to make sure we took that into account for optimal centration. But this is really a patient that's ideal for multifocals. She's motivated to get in them. Obviously, an added bonus that the initial lenses were pretty well centered, minus some lens rotation on the left eye. And then the other piece is that, for dry eye patients, a lot of times, other than maybe some keratitis, their corneas, depending on level of severity, are generally relatively normal, at least normal shaped. And, a lot of these patients, unless they're really dealing with neurotrophic issues and terrible, scarring, most of them have relatively clear corneas and their vision's correctable close to 20/20. So these are kind of your optimal multifocal patients. If you've got a severe cone with a ton of central scarring, it's kind of the same issue with HOA correction. If you've got a lot of scarring right in the visual axis, that's probably not your ideal patient for a multifocal, because you're really just trying to make use of the tissue that's there instead of trying to throw too much at it. So that your patients with good, best corrected acuity and sclerals, that's kind of your optimal multifocal patient. In this case, we did take advantage, even though the patient's in her 70s, we did utilize aspheric distance-centered multifocal in the right eye and the center near in the left. And that was, again, just trying to give this patient the best overall depth and range with that near vision, and that's why we would try that first. So those are kind of the main points with this case, adjusting for the different HVIDs and adjusting for different pupil sizes and different types of multifocals in each eye. So just a couple, nice elements that we're able to give to this patient to make sure that optically she's in good shape. And then with this patient, this is more of our I don't want to say typical keratoconus patient, but his best corrected vision in glasses 20/40 and 20/80. He has actually, I fit him he's been wearing sclerals for years and has done awesome with his lenses. His corneas have been relatively stable over time, and his vision has really improved with the use of sclerals. But let's go ahead and take a look at the next slide there. So if you notice, his HVIDs are definitely larger than average. So this was a really patient where the right eye is 12.8, the left eye 13.1. And you think about, again, if you can't adjust the diameter of a lens, you may or may not have had a trial lens that was adequately covering the cornea, covering the limbus. So this is one where we were able to take advantage of, among other things, adjusting the diameter of the lenses. I think my initial lens that I think at the time our trial lens was a 16.4, and we ended up going all the way up to a 17.1 and a 17.4. And that I think we did that again. We started this years and years ago before we had any of our current technology, but we ended up just based off of his HVID kind of arrived at those numbers, and he ended up doing great with that. And notice we're not really changing the base curve much when we do this. As a matter of fact, that's if you need to adjust central clearance, limbal clearance, you're really not utilizing the base curve to do that so much as you're utilizing the mid-peripheral curves of the lens to really control your central vault and your limbal clearance. So the other thing that we had with this patient was pretty significant pinguecula. And then we had a relatively asymmetric scleral design shape. And I don't think I have any slides of what his actual eaglet eye surface profiler maps look like, but they were what I think we would all consider to be either asymmetric or quad specific. So this was a great patient to utilize those freeform haptics to basically just make sure that we were able to not have any areas on the scleral of impingement, compression, and optimal centration. And then furthermore, we utilized the Optimum Extreme, which is a higher DK material. We did put some I believe we put some HydroPeg just to give those a little bit of extra wettability as well. Yeah, so with this patient, again, you had a relative moderate to significant cone, large HVIDs, able to account for that by changing the diameter, able to account for the asymmetric edges and the edge profile by utilizing some of the freeform edge designs. And this patient's done really, really well for years and has had really stable vision. And he's right around 20/20 with both of those lenses and could not be happier. Oh, and the other thing with this patient is, I think if I recall correctly, back in the day, we had started him with notches. And then as AccuLens transitioned to the vaulted lenses, he was doing okay with the notches. He was complaining that occasionally he would get some air pockets and bubbles in there. And that's kind of the thing, a lot of these patients with notching, they were doing okay, but sometimes okay is not good enough. And if we know we can do better, we have switched a lot of these people from notches to vaults, and they've been really, really happy with that.
Do we have any questions before we move into the next section?
I think there's a question. Do we have a picture of the final lens design? I do have pictures of that somewhere. I don't think I had a chance to add them in here, but we can always, I can send them to Troy and he can pass them along later, any other like individual. I've got tons of pictures all over the place. So anything that, if there's any attendees or anything that want to see stuff or see photos or even some of the eaglet, because the eaglet, even if you guys don't necessarily have the eye surface profiler or Pentacam, sometimes seeing those maps do kind of highlight where the problem areas are and some of the things that we've done to change them. It's just kind of easier to I think it's actually easier to visualize on the map than even just looking at a picture of the scleral on the eye. Because actually, if you look at a picture of a scleral with AccuVault on the eye, you really can't see anything because it's minimal. So if you're just looking at it, I mean, of course, if you're looking at it under the slit lamp, you're going to see a little elevation in that area. But just looking at the eye, you really can't see it, which is kind of the idea, right? It's less disruptive to the patient. It's less disruptive cosmetically too.
All right, any other questions? All right, let's move on to kind of that point using the newest technology.
There was any statistics behind the 70 micron per step. I guess so the thing with that is, a lot of times, so first of all, there is a half step, so you can go 35 microns if you need less. So yes, the short answer is that is feasible. They actually go in half steps. So and I do that a lot. Sometimes, in my opinion, I might look at a fit and say, hey, that looks pretty darn good. And the patient's saying, I just feel it a little bit when I blink, and then to me, that just tells me, well, maybe an edge or all the edges are just a smidge flat, but I don't want to change I don't want to tighten it too much. So in those cases, we'll go a half step, and that's more of our 35 micron change. So that's typically when I would utilize a half step or 35 microns. Much less than that, you're really not changing anything, even if it's possible to do it. You're not, if you're changing something less than that, you're not really doing a whole lot at the edges. Different maybe at the limbus, because we make smaller changes at the limbus. In the case of any severe pterygium or pinguecula or anything that requires a notch or microvault, how can we assess the overall fit if the trial lens is being lifted by the ocular surface? And that is always going to be an issue with trial lens fitting, right? I mean, you can't notch or put a microvault on the trial. And so when you have those pretty extreme elevations, that would be one where you may want to account for that first, meaning you could order a single vision lens, or you could order just a lens in general that's accounting for that pinguecula or pterygium, and then you may want to reassess prescription and things. So that might be a good example of where you could potentially even hold off putting a front toric on there until you got a lens that's centering over top of that, so that you just kind of aren't trying to fix too many things all at once. And that's one where you kind of have to use your judgment. If you're looking at a lens sitting on top of something like that, and you really think, oh man, this thing is just tanking the lens temporally because I've got a giant nasal bump. Okay, then yeah, maybe order an initial lens that you've accounted for that spot first, and then go back and see if there's a front toric fix, or if you want to kind of do it that way. And then alternatively, if you do end up having the some of the mapping technology, that's where that's really super helpful to have the lab be able to measure that first, so that it kind of takes the guesswork out of it. I mean, worst case scenario, you could, if you put toricity in and the lens rotates, you just basically you're reordering it again based on the new rotation. So it's not the end of the world if that happens. And that's basically what we're looking at here with this, the new technology, the eaglet, the Penacam, right? So the idea there is, a trial there's so much built into these trial sets, and you can do a lot without ever even seeing a map of the eye. But of course, a map is more information, and the more information that you have, the better. It does, in my opinion, take a lot of the guesswork out of it. I think someone asked earlier, well, how do you know, how many microns of change do you make to the edges? And the truth is, you don't, at least not exactly. I mean, if you've seen edge lift and you've seen enough scleral lenses, and it sounds like a lot of folks on this call have been fitting lenses for a while, so you guys kind of know what's flat, what's really flat, what's kind of tight, what's really tight, and you probably have some idea of how many microns to change something, just to make it better, right? If a lens is moving on blink, for example, I'm changing that at least 140. I'm changing it at least 2 steps minimum. If a lens is moving because the edges are flat, anything less than that, you're not going to really affect that lens movement at all. So that's one of those things that partially comes from experience with trial fitting, but that's where these maps also take a lot. The maps take a lot of the guesswork out of it, because you can basically just hold your cursor over top of these colored areas. The blues represent depressions, the reds represent elevations, and you can see exactly how many microns of change you might need in any quadrant based on that best fitted sphere. So, they're for your really, super highly asymmetric, highly toric patients, where you do maybe have 800 microns of change between the different quadrants. If you've just done that from the trial set, you might get relatively close, but it probably would take 2 or 3 lenses before you've totally sealed off all of that edge lift. And that's where these maps are super helpful. I like it because even for easy patients, it gives me an idea of what I'm looking at before I even see their eyeball. I kind of know what the eye shape looks like. Is it prolate? Is it oblate? Even a graft is a good example. Some grafts, initially make the eyeball, the cornea is oblate, but then over time, those grafts become more prolate. And so not only is it helpful for me, but I can send that information directly to AccuLens so that they're seeing what I'm seeing. And then they can utilize that freeform curve that starts within the limbus, and they can make the lens basically mimic the shape of the eye, which is, again, super helpful. It just takes a lot of the guesswork out of it. And then the final piece is not only can the lab see that, but I can send these MSR file images basically with one click. There's no saving and attaching anything. It uploads directly to the lab. So it's just, again, a time saver. You know, once I go back and put my trial lens on the patient, and by the way, the eaglet, for example, it actually will tell you, the algorithm tells you which trial lens to select. So it even takes the guesswork out of it from the practitioner side. So if you have that technology, it really is just, you know, as long as you've acquired a good image, it's telling you which trial lens to use, which is going to be the closest. And then it serves as a double check, right? I like putting that lens on the patient, getting an over refraction, making some notes, and sending my information along with the image to the lab, and then it goes directly into their CAD/CAM software, and then they can produce a lens. And we've had a ton of success doing it that way. Let's see, I often observe that the limbal zone is darkened at superior nasal or even more than one quadrant when the LCI is fit at temporal limbus due to decentration. Should I just allow the limbal zone to be darkened, and the lab will help me increase the limbal vault quad specifically? What do you, I guess I'm misunderstanding when you say the limbal zone is darkened.
Dr. Jeff, if you can be more specific on the questions and answers, we will try to help you answer the question that you're assigning us.
So yeah, I'll let you clarify that, and I'll come back to it in a second. But I think this third case is basically just an example, and this is a great one where we had a one and done fit, where we basically were able to utilize the eye surface profiler, and we were able to obtain really good images of the corneas with, you know, pretty significant keratoconus. You see a steep K of about 58 on the right eye, 51.5 on the left, pretty thin corneas. Go to the next slide there, Troy. And then you can see based on that map on the right, so the blues at 12 o'clock and 6 o'clock, if we were to actually hold our cursor over top of those areas are very, very low compared to the temporal side. And then you've got basically a giant elevation on the nasal side. So whether you know, in this case that's a pinguecula, but even if it was just the EOMs on the muscle that was kind of elevating that side, we would have the ability based on this to specify exactly which areas were tightening, which areas were flattening, and which areas were vaulting, and exactly how much we're going to do that. So it's just a really kind of a simple way. Whereas otherwise, if we were using a trial lens, you know, the trial lens would work fine, but it would be a little bit of guesswork as to how many microns we're tightening at 12 and 6, how much we need to flatten that, right? Because the lens is going to sit on the highest area. So to that point of, well, you know, is that going to decenter the lens more than if we had already accounted for that? Yeah, sure, it might, depending on how high that pinguecula is. So if you're just using you know, of course, if you don't have the map, you don't necessarily have all this information before you, but you could see a pretty big pinguecula there, and if it seems like it's pushing that lens way temporal, and you'll know that because those limbal indicators temporally might be you know, way shifted over temporally, and then it may look like nasally that there's not enough limbal clearance there. So that would be maybe an indication that you've really kind of shifted over in that direction, where you would maybe want to account for that first before, say, trying to put, you know, other bells and whistles into the lens. But these are patients where it is really helpful to have that data. So, you know, in this case, you know, we got a lens that fit great right out of the gate, and the patient was off and running, just simply based off of the maps. And then, similarly in the left eye, you see, the green that's basically going from, about 9, 10 o'clock all the way around. And then you've got that depression around 5 o'clock. We're missing a little bit of data at 6. And then you've got that local pinguecula at nasally. So similarly, what would happen if you just put a spherical or toric lens on this eye? It would still probably fit decently, especially because, that lens would likely rotate over towards that depression. So that dot would probably have rotated about 40, 45 degrees counterclockwise on that eye. And then maybe you have to account for the pinguecula, maybe you don't. Not every pinguecula is needing a vault. It just depends. Some pingueculas are small, some are high, some are squishy, some are harder, some get irritated really easily when a lens touches it, some don't. Some of that can be evaluated right out of the gate. If you put that trial lens on the patient and they're telling you that they're feeling it on that nasal side and you just see it slicing right through there, that's a good indication you would take advantage of that microvault. Sometimes they're not bothered by it and you could simply change the lens diameter and maybe avoid it a little bit, and that works too. So, sometimes you've got multiple solutions to the same eyeball. And it really just, there's a couple good options for the same situation. But again, we like having these maps. For us, it serves as an idea of what we're looking at out of the gate. B, it's just extra information. It does help kind of really hone in some of those really complicated asymmetric scleras where there's all sorts of, either local elevations or just big differences in elevation between the meridians and quadrants. So for us, again, it's something we started using in around 2018, and their technology has drastically improved over time as well. And Aculens was, correct me if I'm wrong, I think they were one of the first labs to have their algorithm in place with that particular piece of equipment, which has also given them the longest period of time to continue to tweak that algorithm. And that pays dividends because it's spot on. I mean, as long as you have good image, it really does a good job of helping to design the lens.
All right,
So the question is, how do you account for missing data on the ESP? Two different ways. One is get another picture. So I think in this case, we did have another picture, and you can send, let's say you're missing data inferiorly. I could get a second image that was more focused on the bottom, and I could send that partial data to Aculens and they could utilize both. So that's one option. Option number two is the Eaglet actually has a situation where you can do what's called smart merge, where you can actually take two images if you're missing data and merge them, and it will create a third separate image that has the two pieces of data merged. So that's another option. And the third is if you just sent them this image, Aculens would just simply extrapolate what they think it looks like based on the data basically 180 degrees away, which is not ideal, of course. But again, depending on certain people's anatomies, you may or may not be able to get all of the data, just depending on if they've got tight lids or small apertures, or who knows what the reason might be. But certainly we do our best to try and get data 360 degrees around. And this is also where it's helpful to put the trial lens on, because you can leave notes when you send this data to the lab and say, hey, the Eaglet nailed everything. And by the way, I'm noticing, the 6 o'clock or, from 6 to 9 o'clock is doing this. And then you leave that in the notes, and then the lab knows what to do. So I think it's a good collaboration. Again, in a perfect world, yeah, we've got perfect, beautiful images on everybody, but that just does not always happen. But there are certain ways around that.
Any
Oh.
other questions?
I guess to summarize, whether you have map data or not, I mean, the trial lens has so much built into it that it's a really, really powerful tool. Given the different diameters that come in the trial set, you can really do a ton, and you can learn a lot just simply by utilizing everything that's built into those lenses. And again, from just starting out 10 years ago to where we are now, I personally I love having a lens that can do it all. I don't like having to switch between sets and companies, and it's nice just knowing that, hey, if we need it to happen, they can do it. And having that all built into one lens. It's also really nice knowing that AccuLens has invested in continuing to drive their technology forward. And certainly we've seen that with the eye surface profiler. I mean, they've been absolutely on top of it, at the forefront of all that stuff. And I don't have a Pentacam, but my understanding is it's the exact same integrations with their focal points and CAD/CAM software. So yeah, I'm just reading back through these questions here. Often see that there's some degree of limbal bearing. So that's a good point. So I think that you do want to really evaluate the limbal clearance mainly based on the temporal sides, not necessarily on the nasal side. The limbal bearing will be improved, but will indicate the lens is too large. Should I stay with the lens size with the ideal? And again, I don't know that there's a wrong answer there. You can simply adjust limbal clearance and not change the HVID. Right. So I mean that is an option. I think it's just nice to have the option to increase, if all else looks good, I don't always necessarily want to tweak the limbal clearance. And not that would necessarily, like, let's say if we increase limbal clearance, you may end up changing the approach towards the edge of the lens. And maybe we don't want to do that. Sometimes it's nice to simply go a little bigger, a little smaller, depending on what you're trying to do. But I think both would work. You could just manipulate the limbus in that area, or you could change the diameter either way.
Yeah, I think Alex is absolutely correct. What it is the LCI really is an indicator to at least get to the target best fit out of a trial set. Making a lens larger or smaller based off of other factors might be necessary. So as I said, we can increase the angle or the radius of the limbal curve itself in order to vault that area a little bit better. Pushing towards, the philosophy of creating prolate or oblate bisphere elevation designs is really where that would land. There is no set point, so everything is customized. And additional to that, when designing a lens via profilometry, regardless of ESP or Pentacam CSP, the lenses themselves typically, on average, will be larger than what you normally would fit utilizing the trial lens and LCI. So there isn't anything wrong with that. The whole philosophy, again, is larger OZ, larger lens diameter. So if it is a little larger to get you to that success, not a problem if the patient can tolerate that.
Other than that,
Great,
yeah.
guys. That was a great presentation. So remember, this is the first freeform lens in the Middle East and Asia. So we're extremely happy that you can try these lenses on your patients. Please, this is the right moment to ask any question. We have Troy, we have Elisa, we have Dr. Alex. So please, if you have any questions, let us know. What is the larger diameter that you can go to? We can go up to 20 mm, doctor. And just like Dr. Alex was saying, I work with other scleral lenses in the market, and they do have limitations. With Smartlens Pro being a free form, you can tell us exactly what modifications you want on that lens, and most likely we're going to be able to do it. Same price, yes. From 14.5 to 20 mm, same price. We don't charge any different pricing for larger diameter lenses, doctor. Any other questions, doctors? I know that King Khalid Eye Hospital was here. They fit a lot of scleral lenses in Saudi. So if any of the doctors from the King Khalid Eye Hospital have any questions, this is the right time to ask them.
And I just want to say thank you to everyone. And I also plan on, I got a little guy at home, but barring any unforeseen illnesses that come up, I hope to be at IC or at Global Specialty Lens Symposium in January. So if any of the docs or anybody happens to be out in Vegas in January, certainly come find me and be happy to talk more about it.
Perfect. Thank you so much, Dr. Eliza and Troy. I hope everyone has a wonderful night and a wonderful afternoon in the United States. I appreciate it. Thank you so much for joining.
Take care.
Take
Bye-bye.
care. Thanks, Troy. Thanks, Alex. Thanks, Eliza.
Thank you.